Hello and welcome back. Today we'll be doing question 5 from the 2014 math paper. So, let's get started. Question 5 for all applicants. Poets use rhyme schemes to describe which lines of a poem rhyme. Each line is denoted by a letter of the alphabet, with the same letter given to two lines that rhyme. To say that a poem has the rhyming scheme A, B, A, B, C, D, E, D indicates that the first and third lines rhyme, the second and fourth lines rhyme, and the sixth and eighth lines rhyme, but no others. More precisely, the first line of the poem is given the letter A. If a subsequent line rhymes with an earlier line, it is given the same letter, otherwise it is given the first unused letter. For the purposes of this question, you can assume that we have an infinite supply of letters, not just the 26 letters of the alphabet. The purpose of this question is to investigate how many different rhyme schemes there are for poems of n lines. We write Rn for this number. Part 1. There are 5 different rhyming schemes for poems of 3 lines, so R3 is equal to 5. List them. Let CNK denote the number of rhyme schemes for poems with n lines that use exactly k different letters. For example, C32 equals 3 corresponds to the rhyming schemes AAB, ABA, and ABB. Part 2. What is CN1 for n greater than or equal to 1? What is CNN? Explain your answers. Part 3. Suppose that 1 is less than k is less than n. By considering the final letter of a rhyming scheme, explain why C n k is equal to k c n minus 1 k plus c n minus 1 k minus 1. Part 4. Write down an equation showing how to calculate Rn in terms of c n k. Hence, calculate R4. Part 5. Give a formula for Cn2 in terms of n for n greater than or equal to 2. Justify your answer. Pause the video now to have a think, and once you're ready, restart to see if you were correct. Let's get started with part 1. So, firstly, we'll just list out all 5 possible rhyme schemes for R of length 3. These are AAA, AAB, ABA, ABB, and ABC. Now, let's move on to part 2. CN1 is equal to 1 because the scheme must contain just A's, and there is only one way of doing this. CNN is also equal to 1, as the only possible scheme is A, B, C, continuing all the letters to the nth letter, which contains all the first n letters of our infinite alphabet. Now we'll do part 3. We'll need to split this into 2 cases. Firstly, that the last symbol matches an earlier one, and secondly, that the last symbol does not match an earlier one. In the first case, there are Cn-1, k, ways to choose the first n-1 symbols, and then k choices for the last symbol. Similarly, for the second case, there are Cn-1, k-1 ways of choosing the first n-1 symbols, but then only one choice for the last symbol. Putting these together, we can obtain that Cnk is equal to k c n-1 k plus c n-1 k-1 as required. Now we'll move on to part 4. Firstly, we'll realise that Rn is simply the sum from k equals 1 to n of c n k. Next, we'll construct a table of all values of c n k up to n equals 4. We'll now fill the values in for when n equals k and when k equals 1, and then we can use the formula above to fill in the remaining values. Now, we'll look at the last row of the table where n equals 4 and sum all the values to obtain that R4 is equal to 15. We can now move on to part 5. Here, we'll notice that Cn2 is equal to 2, Cn minus 1, 2, plus Cn minus 1, 1. This second term simplifies down to 1, and we now have a recurrence relation. We can solve this to obtain that Cn2 is equal to 2 to the n minus 1, take away 1. If you liked our video, please like and subscribe, and we'll see you next time for some more fun maths problems. Thanks for watching, and goodbye.